Hi, today we're talking about trigonometric functions and acute angles. So here is your basic 6 trigonometric ratios. So we know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So the cute little phrase people know to memorize this is SOHCAHTOA. So SOHCAHTOA is sine is opposite over hypotenuse, cosine, ka, is adjacent over hypotenuse, tangent is opposite over adjacent. Now cosecant is attached to sine, and it's just a flip of it. So it's hypotenuse over opposite, cosine is secant, which is hypotenuse over adjacent, and cotangent is adjacent over opposite. And so this is all determined by an angle that is given. So you must look for that. Let's go ahead and try a problem with it. So if we take a look at this, we have our angle marked here. So before we even get started writing these things, the one across from it, this one is our opposite. This one's our adjacent, and our hypotenuse is always the one across from the 90 degrees. So from here, we're just going to write the 6 ratios. So sine of theta equals blank, cosine of theta equals blank, tangent theta, and then we're going to do cosecant of theta, secant of theta, and cotangent of theta. If you notice, everything is attached with a co. So sine goes with cosecant, cosine goes with secant, tangent goes with cotangent. So using the SOHCAHTOA rule, we can find this. So OH, so opposite hypotenuse, so 5 over 13. Cosine is AH, so 12 over 13. And TOA, opposite over adjacent, so 5 over 12. Once you get these, you get the rest for free, as long as you line them up properly, sine with cosecant. So this one gets 13 over 5, 13 over 12, and 12 over 5. In other words, I just flipped them. That's all you have to do. Go ahead and try this problem. Try this problem. Try this problem. Okay, what if we know one ratio? Can we find the rest? The answer is yes. So draw a right triangle. I'm going to draw it like this. Doesn't matter how you draw it. I'm going to pick an angle. We'll call it right here. Make that my theta, if you will. So we know tangent is opposite over adjacent. So opposite would be 15, adjacent would be 8. And how do you find this missing side? We'll use the Pythagorean theorem. If you use the Pythagorean theorem, which is a squared plus b squared equals c squared, these are a's and b's. C is always your hypotenuse. So we go 8 squared plus 15 squared equals c squared. If you solve this all out, you end up with 17 equals c. So that's your hypotenuse. This is opposite, adjacent, and hypotenuse. So knowing that, we can find the other ratios. So sine is going to be opposite over hypotenuse, so 15 over 17. Cosine is going to be adjacent over hypotenuse, so 8 over 17. Tangent we already have, it's given, which is 15 over 8. And now from there, we get the rest. Cosecant theta is 17 over 15. Secant, is 17 over 8. And then cotangent is 8 over 15. And that's how you can use one to find the other. You just got to use Pythagorean theorem to find the missing side. Go ahead and try this problem. Try this one. Now, to find the missing side length, this is where our classic word problems come into play. So it says a fire truck has an 84-foot ladder extended against a building, forming a 55-degree angles from the top of the truck. So we got the truck. There's my truck. Got this ladder, which is 84 feet. It's at a 55-degree angle against a wall right here to a window. The truck is 8 foot. It says they're trying to reach a window that is 75 foot. That's what they want, 75 feet right there. So above the ground. Will they be able to reach it? Well, first we're focused on this triangle right here, which goes like this. It's 55. This is 84. We got to figure out this side. So that is opposite over hypotenuse. So we're going to use sine. So sine of 55 equals opposite x over 84. And so we do this by solving. So 84 sine of 55 equals x. So if we plug that in the calculator, we get 68.81 feet is x. But the answer is not no, because the truck is 8 foot tall. So we add 8 to that, and we get 76.81 feet. So will it reach it? The answer is yes. It will reach. Go ahead and try this problem. Try this problem. So let's talk about special triangles. So the first one is a 45, 45, 90. So if you take a look at it, it's half of a square. So it goes like this. It goes, if the side length is 2, that means this is 2, and this side is 2, because these are the same. And so automatically this is 2 radical 2, because the ratio always goes radical 2 for here. Okay, so the general one that you might see is one with 1s on the side, where it's 1, 1, radical 2, like that. That's your typical 45, 45, 90. This is just double that. Everything's been multiplied by 2. So from there, we can find the 6 trig ratios. So we got sine of, I'm going to pick a side. I'm going to call this side, where was that? N, I don't know, M, O, something like that. So we're going to use that. So from here, we're just going to pick one of the 45s, because it's all 45. So I'm going to call it sine of N. So this one's opposite, adjacent, hypotenuse. And we get some patterns here. So sine, cosine, tangent. We get cosecant, secant, and cotangent. So sine would be opposite over hypotenuse, so 2 over 2 radical 2, which if you clean it up, it ends up being radical 2 over 2. Cosine is the same thing, 2 over 2 radical 2, so we already know that it's radical 2 over 2. And then tan will just be 2 over 2, which is 1. So if we take a look at the cosecant, we're going to get 2 radical 2 over 2, which is radical 2. So secant's going to be the same, so it's just radical 2. And cotangent is just 1. So let me do a quick review on how I get from here to here. So 2 over 2 radical 2 gives you 1 over radical 2. And you multiply top and bottom by radical 2. And that's how you get that. Go ahead and try this problem. Now for a 30, 60, 90 triangle, the ratio goes like this. I'm going to write the general one first. 1, 2, and radical 3. Where this is 30, this is 60. So that's a typical 30, 60, 90 triangle. So this right here is saying J, K, L. This one's 30. And it says LK is 4. So we can find the other sides using this pattern. If this is 4, this is 8, and this is 4 radical 3. And so now we find all the values. We're going to find the sine of J. So cosine of J, tangent of j, cosecant, secant, cotangent. So basically what we do here is this is opposite, adjacent, hypotenuse. So same story as before. We get 4 over 8, which is 1/2. Cosine, we get 4 radical 3 over 8, which is radical 3 over 2. And tangent, we get 4 over 4 radical 3, which ends up being radical 3 over 3. And so from here, we just do the inverse. So this one's just 2. This one is going to be 2 radical 3 over 3. And this one is going to be just radical 3. And so you could actually, if you want to cheat it a bit, you just use the general one. It always reduces down to here anyways. So if you notice, all the numbers in the answers are these numbers right here, not these ones. They're connected though. All right, go ahead and try this problem.